Cloud computing has revolutionized the way organizations deploy and manage their workloads. At its core, cloud compute provides virtualized computing resources over the internet, allowing users to create, manage, and scale virtual machines without the need to own physical hardware. This means businesses can shift from large upfront investments in servers to a flexible pay-as-you-go model. Major providers like Amazon Web Services, Microsoft Azure, and Google Cloud Platform offer robust platforms that support everything from startups to global enterprises. With cloud compute, you gain the ability to quickly deploy resources, scale up or down based on demand, and focus more on innovation rather than infrastructure maintenance. This foundational shift is why cloud compute is considered a critical service in modern IT. Let's compare traditional servers with cloud compute. Traditionally, organizations had to purchase physical hardware, which meant high upfront costs and limited scalability. Expanding capacity required buying and installing more servers, a process that could take weeks or months. In contrast, cloud compute uses virtual machines, allowing instant capacity adjustments and automated deployment. The cost model shifts to operational expenditure, where you only pay for what you use. This flexibility is a game changer, enabling businesses to respond quickly to changing needs. Whether you're a small startup or a large enterprise, cloud compute removes barriers to innovation and growth, making its resources more accessible and efficient than ever before. Virtual Private Cloud, or VPC, is a key concept in cloud networking. Think of a VPC as your own private section within a public cloud provider's network. Even though your data shares physical hardware with others, your VPC is logically isolated, like having your own secure hotel room in a large building. You control the networking environment, from custom IP address ranges to subnets, route tables, and gateways. This isolation ensures your workloads are protected from public exposure, and you can enforce strict security policies. VPCs are essential for organizations needing enhanced security, traffic management, and hybrid connectivity with on-premise networks. They provide the flexibility and control required for modern enterprise applications. Let's break down the core components of a VPC. First, you define an IP address range, which is then divided into public and private subnets. Public subnets are accessible from the internet, while private subnets remain hidden. Route tables determine how traffic flows within and outside the VPC, and the Internet Gateway acts as the entry and exit point for public communication. Security groups and network ACLs function as virtual firewalls, controlling inbound and outbound traffic at both the instance and subnet levels. This layered approach allows you to deploy resources securely and efficiently, tailoring your network to specific application needs. Each step, from subnet creation to access control, is designed to maximize both flexibility and security. Make these concepts more tangible, let's use a hotel analogy. The public cloud is like a hotel building, while your VPC is your private room, secure and isolated. Security features are like your room key and door, controlling who can enter. For example, a company might host its web server in a public subnet for internet access, while keeping its database server in a private subnet with no direct internet connection. Only the web server can communicate with the database, ensuring security. In the banking industry, organizations like JP Morgan Chase use VPCs to isolate sensitive financial applications, keeping customer transactions secure while leveraging the scalability of the public cloud. This blend of privacy and flexibility is what makes VPCs so powerful in real-world scenarios.